So, welcome to Big Data and Hadoop demo. So, let me introduce myself first. Myself, Murthy. I am working in from last 8.5 years in IT. So, where initially I worked in TCS, Tata Consultancy Services for 6 years, completely on Java JDE technologies. So, after TCS, I was in Mahindra Satyam for almost 2 years. Guys, could you mute yourself so that if you have any doubts, you can unmute and ask. If I mute it right, I don't know if somebody has doubt, right? I cannot do that again. Thank you. So, in 2011, I joined in Mahindra Satyam. So there I got trained on big data and Hadoop from Cloudera. So after training, I finished my certification there. Okay, as a developer. So from 2011, I'm working on completely big data and Hadoop technologies. Okay. So in Satyam, right, I got been assigned for Thomson Reuters client. For Thomson Reuters, I worked for almost more than 1 year, completely on big data. It's on legal domain. We provided, we did some batch analytics for Thomson Reuters. Okay. So after that, I worked for one more client called Standard Electricals. It's France-based company. It's we did on Amazon cloud environment. Okay. Real-time analytics we implemented using Hadoop technology stack, using Amazon EMR and Amazon S3 on EC2 environment, cloud compute environment. So after that, I was also from last 8 months. I was also working as a consultant for one more company called Lumris. This US-based company belongs to Essence Healthcare Group. It's on healthcare domain. So there completely I worked on big. I mean there I was working as a consultant. Just we'll work a couple of hours per day. So we provided some big data solution for their business intelligence. What they are doing with traditional systems. Okay, they migrated to completely into Hadoop. So along with that, from the last 6 months, I'm taking online and offline trainings. Also providing job support for 2 associates in US. Okay. So this is more about me. And recently, I joined in United Health Group. Okay. There I has joined as Hadoop architect. Okay. So there also we are started doing one big Hadoop project. Okay. It's again, it's not analytics. It's something like data transformations. What we are doing there. Okay, data transformations and integrations. Okay, it's a big project. Currently performing as a architect role. Okay, so there is more about myself, guys. So let me start the demo. Okay. So during the demo, if you have any questions, you could put me. You could either chat me here. Okay, you could ping me here, or you could unmute and you could ask me. So I heard that you all guys, most of you guys are did MS in data analyst and looking to learn for Hadoop and looking to change your career to big data analytics, right? As a data analyst. Okay. So let me start the demo first. So during the demo, if you have any questions, you could fire me up. Okay. So before going to presentation, let me start the demo with some real-time use case. Okay. Let's take an example. ICICI Bank. Okay, some bank. Assume a customer went to ICICI Bank. Customer went to ICICI Bank. Okay, and he requested for 1 year bank statement. Bank statement. and the customer representative, he will log into the customer account, he will give the statement back maximum something like 3 minutes or 5 minutes. As a maximum he will give the statement in 5 minutes. Okay. But if the same customer went to ICICI Bank, okay, now he requested for some 10-year bank statement for some purpose, like for house loan or something, he requested for 10-year bank statement. This time your customer representative, okay, he will say, sir, you are requesting for 10 years data, that is historical data, okay, historical data, so which I cannot serve from here, okay, I have to send request to backend systems, okay, backend guys, and your request will be served in next 24 to 48 hours, okay, and they will charge some amount for that, okay. So if you see, they will take some 24 to 48 hours, okay. So because if you see here, this 1 year data, 1 year or 2 years, 3 years data, right? This data will sit in our traditional RDBMS systems, okay, relational database management systems like Oracle, okay, like Oracle or MySQL, or could be DB2 or could be Sybase, something, any RDBMS systems, okay. The recent data, like last 3 years or 2 years data, they will sit always in your RDBMS systems. But if you go to this 10 years data, 10 years, 20 years, 30 years or 40 years, the complete history of the customer, okay, or even organization, they will store in backend systems called warehouses, or we call data centers. They will store in these backend systems, okay. So there are many warehouse systems already existing in the market, like Teradata, something Neteja, and we have something called DataStage. We have many things like this, okay. So if you see this historical data, what I am saying, it will say in these backend systems, okay, and your ICICI Bank application, what the customer representative will access, okay, for that application, okay, he could access only these RDBMS systems. They cannot access these warehouse systems, because these warehouse systems holds large volumes of the data. Like, since it's historical data, right? Historical data means there will be in huge size, okay, like in terabytes or petabytes of the data, okay. And processing these terabytes and petabytes of the data, they cannot serve it from our real-time applications, the web applications or something, enterprise applications or something, okay. They cannot do it from the real-time applications. So is the reason these systems were maintained as a backend warehouse systems. So in the customer raise this request, your customer representative will send this request back again to the backend people, okay, like this warehouse administrators or warehouse developers, whoever is there, okay. So they will process this request and they will send the response back to customer, okay. So if here the main difference is the size of the data, but if you go to big data, okay, big data, okay, even if it is 1 year data or 2 years data or 5 years data or 10 years data, 20 years or 30 years, any amount of the data, it can serve in the same time. That means if it is 1 year data, it will give you the response in 5 minutes. If it is 20 years data, it will give the same, the response within same amount of the time, okay. So it is mainly, it serves any huge volumes of the data in the same amount of the time by following a mechanism called parallel processing mechanism. It processes your data by following this architecture called parallel processing mechanism, Okay, but if you go to these guys, RDBMS systems, okay, or even these warehouse systems, they follow something called sequential processing mechanism. Okay, they follow something called sequential. I mean, the architectures they designed this old systems, these traditional systems, they designed with sequential processing mechanism. But Hadoop newly designed with parallel processing mechanism. Okay, so this is one main advantage of the first advantage and bigger advantage why the companies or the domains or the organizations who are holding high volumes of the data, they do see the benefit of migrating to Hadoop, since they can process this data, okay, how they are doing before, like within days or hours, which the processing amount of the time they are taking to process like days or hours with the traditional systems. Now they could able to the same processing like within very small time. Okay, very small time. Suppose if you take some use case, fraud detection, okay, like credit card fraud detection or some medical claims fraud detection. Okay, something in our in my, let me take in my company itself, the before company as consultant I working, okay, that claim fraud detection. Okay, so before they something like if they assume like there is a fraud happening, okay, to detect the fraud is really happening or not with existing data, to do this analysis it used to take some like how many, 7 days. Okay, 7 days. I mean to analyze it with the complete using the software and with some manual mechanism also, it used to take 7 days. But now after migrating to Hadoop, right, they see advantage like if there is any fraud happening, they could able to detect within some 10 hours, within a single day. They could able to detect immediately very fast within 10 hours using the Hadoop system after migration. Okay, so that is a range. That is a range like how fast the Hadoop runs to give the analysis very fast. Okay, so this is one main advantage. Next, going forward, okay, so these guys RDBMS systems, okay, these RDBMS servers like Oracle or MySQL something, they have certain limit, okay, while storing. An Oracle server maximum can store 16 terabyte of the data. Okay, a single Oracle server can store maximum 16 terabyte of data. It cannot serve more than that. But these warehouse systems, they can store as much of the data. Okay, before that, these warehouse systems, right, they will run on clusters. Okay, so you would have know what is a cluster. Cluster is nothing but collection of systems. Okay, collection of computers or systems, okay, or nodes, we call normally as nodes. Okay, collection of nodes interconnected to each other and can do intercommunication with each other. That means if I have a cluster of 10 systems, that means there are 10 nodes in my cluster. In these 10 nodes, any system can talk with any other system. Okay, each system, like one system can talk with all other 9 systems. Similarly, other system also can talk with the remaining systems. Okay. So cluster is a collection of nodes which can do intercommunication and well connected in a network. Okay. So these systems, these warehouse systems, data centers, they will run on clusters. Okay. And these clusters were designed with an architecture called master-slave architecture. And it was designed with master-slave architecture. Okay. That means if I have a 10-node cluster, okay, as we discussed, I have a 10-node cluster, one single cluster with 10 computers. Okay, out of these 10 nodes, one will perform master role, and remaining 9 will perform slaves role. That means there will be one master, and remaining n-1 nodes will be slaves. Okay, so these guys will run on clusters. Okay, and again, Hadoop also runs on clusters. Okay, but we'll come to see what is Hadoop cluster later. So here, as I said, Oracle server maximum can store 16 terabyte. Okay, so now let's assume I have one Oracle server running in my organization. So at some point of time, it will get full, right? Assume the 15 terabyte is the storage is occupied. Okay, only 1 terabyte free space is left. At the time, the DBA, database administrator, he will escalate to the client or project management. Sir, we need to add extra storage space to the existing server, extra storage disk to the existing server, or we need to buy a new server. Okay, we need to add one more server. So if they buy a new server or adding a new storage to the existing server, they have to restart the complete RDBMS server. That means they have to restart the existing server also. Okay, so certainly there will be certain downtime when they restart this existing server. Okay, so the downtime may impact the business who are accessing the applications at the time from who are accessing from, that means by end users. Okay, that means if your database is down, there will be impact on the applications since they cannot access the applications in the downtime. Okay, so this is one drawback here, even in these warehouse systems. Okay, please concentrate. So I said like these runs on clusters and they will have one master node and n-1 slave node. Okay, see these clusters also something, assume 10 nodes I have. Okay, so each node is holding some 1 TB of storage, 1 TB hard disk. Okay, so that means it is, the cluster can store maximum 10 terabytes of data. Okay, so if the cluster also sometimes it will get full, assume like all the disks are getting full, the storage is getting full, I mean like 10 terabytes is getting occupied. So now what they do is, normally they will enhance the cluster. That means they will add new nodes to the existing cluster. They will buy some more 2 or 3 more nodes and they will add to the cluster. But when they are adding new nodes to the cluster, existing cluster, okay, they have to again restart the entire cluster, because otherwise until unless they restart the cluster, your master cannot detect the new nodes. Okay, the master system, okay, it cannot detect the new nodes what has been added to the existing cluster. Okay, so that is little difficult here. Okay, so certainly there will be certain downtime. Okay, where the little difficult here. Okay, so that is why means these guys, these warehouse systems or data RDBM systems, they follow something called vertical scalability. They follow vertical scalability. But Hadoop follows something called horizontal scalability. Horizontal scalability. Okay, horizontal scalability. That means, since I said Hadoop also runs on the clusters. Okay, so it also runs on master slave architecture. So when you are adding any new nodes to the Hadoop cluster, the current Hadoop cluster which is running, it will never disturb. That means it will never down. It automatically detects that new nodes what is being added to the Hadoop cluster. Okay, that is with this horizontal scalability. We also call this as linear scalability. This is one more advantage in Hadoop. Okay, because these guys are facing bottlenecks when coming to the scalability. Okay, scaling the existing cluster to by adding new nodes. Okay, so the next one here is hardware failures. Hardware failures. So we have to see the impact of our systems. Like if RDBMS server is down, obviously applications will be down. They cannot access this RDBMS server, okay, until unless it's up again. There will be huge impact if the hardware is failed. Okay. Similarly, here in the clusters, something out of your cluster 10 nodes, something, assume one node is failed. Okay. So what will happen is, if the one node is failed, your cluster will not be down, cluster will be running. But the applications which are running in the cluster and are depending on the failed node, okay, the node which has failed, those applications will be killed. Okay, because here, okay, this cluster side, these backend systems, warehouses, data centers, they are mainly to do batch processing of the data. Okay, so this batch applications, right, in these warehouse systems or data centers, they will run for hours and even for days. The applications will run for hours and days. So something, while one application, it's almost 90% of the application processing is done, execution is done. Okay, something if one node is failed in the cluster, but this application has dependency on that failed node. Okay, so the application will be down. Again, they have to fix it and they have to restart the application, and the application is again going to consume the same amount of the time to process the data. Okay, which is tedious, and which is will take more time to do analysis. Okay, so these hardware failures here are there is a huge impact, and this is again, okay, this and next one is there. Okay, these two are something very important features clients are seeing. Okay, like cost advantage. Okay, cost advantage and high availability. That means the clusters will be always high available. There won't be any downtime with these two features. Is the reason many projects in the world are migrating to Hadoop. And how Hadoop is going to handle hardware failures is something called using replication. So if it is Hadoop cluster, the same cluster, assume this is Hadoop cluster, the 10 node cluster. Even 1 node, 2 node, 3 nodes fails. Okay, 3 nodes, 4 nodes. How many nodes fail? Okay, still your Hadoop cluster is intelligent that it will make your application successful without killing it. Okay, even if nodes are failed, even the nodes are not available, still it will make your application completed successfully. Okay, we do it using something called replication. Okay, and the next one is cost. Okay, you could know the cost of this RDBMS servers. There will be lakhs. Okay, like there will be in like 15 lakhs, 10 lakhs, something, these servers. Okay, because they have to buy the server and they have to provide support for the server again. Okay, there will be huge price for that. Even if you go to these warehouse systems, okay, they run only with some minimum recommended configurations. Okay, they need some 16 GB minimum, 16 GB RAM for the slave nodes. Okay, they also run some with minimum reliable hardware. Okay, but Hadoop something runs on commodity hardware. Commodity hardware means cheap hardware. Okay, cheap hardware and reliable hardware. Okay, so client, it's a cost benefit for the projects and the clients who are migrating to Hadoop because it runs on the cheap hardware. Suppose assume it will run on 4 GB RAM, 8 GB RAM, 16 GB RAM, 32 GB RAM. It will run on 250 GB hard disk, 500 GB hard disk. Okay, even it will run with the base core processors. Okay, so something, assume I have a cluster in my company, some 10 node cluster. Okay, so I have my desktop system at my home. Okay, if I take my CPU cabinet, okay, which is some 4 GB RAM. Okay, and if I take it and add it to this Hadoop cluster, the 10 node cluster. Okay, if I add it, your Hadoop cluster will not say like, boss, you got some cheap 4 GB RAM hardware. Okay, I cannot take it. Don't say like that. Still it will accept your cabinet, CPU cabinet, and it will say, I will accept it and I will use it, how much I can use it. Okay, based on this capacity, it will assign some small responsibilities for this small system. It will try to use it. So Hadoop will support any kind of configurations and it supports any kind of hardware. Okay, which is a cheap hardware. Okay, that is one biggest cost advantage for the many companies. Okay, but the problem with this commodity hardware, since it's a cheap hardware, they will fail frequently. Okay, obviously it's a cheap hardware, okay, which is not much reliable. They will fail frequently. But again, Hadoop has a solution for hardware failure. So these two guys are dependent on each other. Okay, so these two features are very, very important coming to setting up a Hadoop cluster for administrator. Okay, So the next one is type of the data, okay, and size of the data. We know RDBMS systems can handle only structured data, the data which is schema. Okay, you will have metadata, you will define tables or whatever it is. After defining the schema, you will load the data into tables. Okay, and again, these guys, this warehouse system, right? These guys can process both structured and of course semi-structured, and they can partially process unstructured data. We'll see what is unstructured data and semi-structured data. They can partially process unstructured data. Okay, these warehouse tools, the existing tools like Teradata, what I said, right? ETL tools or something. Okay, they can process this, but they have other drawbacks as we discussed before. Okay, so this is the reason Hadoop can serve any type of data again. Okay, but coming to this type of data, right? These guys also can do it, but these guys have other drawbacks. What we discussed till now. Okay, so Hadoop is meant to process any type of data like structured, like your RDBMS data, relational data, semi-structured data. Semi-structured means like XML, JSON files, okay, and unstructured data, which is very important because Hadoop is mainly for to process this unstructured data. Okay, to do analyze it, to analyze this different kinds of data. Okay, so because if you go to real world, if you assume the total data available in the world is 100%, okay, so the percentage of the data which is structured is only 20%. Okay, 20% is structured data and remaining 80% is unstructured data. We have vast number of sources that are generating these unstructured data. Okay, like we have many number of sources. Like if you take some, what is that? Yeah, climatic data, weather data. Okay, sensor data, GPS data, satellite data, call center data, social networking data like tweets, Facebook charts, images, videos, YouTube data, videos, okay, graphs, blogs, okay, and biometric data. Okay, so there is vast number e-commerce sites data, vast number of sources are there which are generating this unstructured data, and this unstructured data could be in any format. Okay, it could be in text format, it could be in binary format, it could be in some what is that binary format, images format, okay, videos, XML format, a JSON format, it could be some sequential format, it could be in compressed format, okay, like tar files, ggf files, jar files, okay, it could be in any format. Okay, we have some hundreds of formats is there available in the world. Okay, could be any format, and it's difficult and biggest challenge for Hadoop developers or data analysts, okay, to understand the format of the unstructured data. First, you should analyze what is this data, how could we process this data, okay, can we do have which ecosystem, I'll tell you what is ecosystem, which solution has to choose in Hadoop to process this unstructured data. So it is the biggest challenge for Hadoop developer or data analyst to understand this unstructured data first. Okay, so Hadoop has many solutions to process this structured, semi-structured, and unstructured data. Okay, and again, Hadoop can process any volumes of the data, like it can process gigabytes of the data, or terabytes of the data, or petabytes of the data, or exabytes of the data, or yottabytes of the data, or gigabytes of the data. Okay, this is a data calculation. How do you do? Gigabytes, terabytes, petabytes, exabytes, yottabytes, gigabytes. Currently in the world we have data which is in exabytes. Okay, so Hadoop can do any type of the data and it can process any size of the data. The last but not least is data analysis, that means development, application development to do analysis. Okay, So Hadoop is not a single solution to do analysis. Okay, Hadoop has some bunch of solutions available that you could pick any one solution to do data analysis. Okay, so Hadoop has many ecosystems evolved around it. Okay, so something you could do in MapReduce, Hadoop MapReduce, or you could do in Pig, or you could do in Hive, or you could do in HBase, or you could do in Cassandra, or you could do in MongoDB, or you could do in Mahout, or you could do in Impala, or you could do in HBase, or you could do in DynamoDB, or you could do in cascading, or you could do in R Hadoop, okay, or you could do in what is that? Impala, DynamoDB. We have many things like this: cascading, Cassandra, Pig, Hive. We could do in Scala. We could do in Star. We have many ecosystems. Still, there are many things are coming. Okay, so you could use any of these solution to do this data analyst part. Okay, that means analyzing the data and the development of solution for this business requirement. Okay, so again, when coming to this, every ecosystem has its own purpose. Okay, has its own advantages and disadvantages. Okay, if you see. Okay, so again, as I said, Hadoop is mainly to do data analytics. Okay, Hadoop is mainly to do data analytics, and this data analytics are again divided into data analytics okay, data analytics is divided into two levels. One is real-time analytics, and one is batch analytics, what we call static analytics. Okay, so it's important to understand few of these ecosystems, at least in depth, some 3 to 4 ecosystems. Okay, at low level, how to some like 2 ecosystems which were serve for real-time analytics, and some 2 ecosystems which serves for batch analytics. Okay, so this is a like data analytics, and there is one more role called data scientist. We are going to discuss what is data scientist and what he will also do. Okay, so this data scientist will use some tools like Mahout or some Hadoop, okay, to mine the data. That means they will actually, what they do is they will try to introduce the new formats of the data. Okay, the format which is not there in the before, they will try to analyze the new formats. Okay, and again, if there is data which has some complex formats with multiple data formats, there is a data, I have some file with complex multiple data formats. That means some part of the file is with one format and some part of the file is with one format. In those cases also, we do mine these files using these data scientist tools like Mahout, R, and we have many things is there. Okay, so we do it. Okay, so developing these things, okay, you need to be proficient at least in some 3 to 4 ecosystems, and MapReduce is a base for Hadoop. Okay, so if you choose the MapReduce for development, I mean to develop this data analytic part, okay, the analysis requirements, you should know some programming language like C++. You should know some C++ or Java or Python, something, any language, any scripting language, Python, Ruby, or some shell scripting, or some parallel scripting, or some PHP. Any language is sufficient, okay, to do this what is that MapReduce programming. Okay, but in our course, right, I'm going to cover Java. Okay, if from the MapReduce programming we are going to do in Java, as Java is most familiar language. If you know Java, fine. Otherwise, if you know, if you don't know, I'll be taking some 3 hours Java class, okay, 3 to 3.5 hours Java class, giving high overview of what is Java, what is OOPS concepts, how do you write Java programs normally using the OOPS. And again, Java, right, you don't need to know advanced Java or something, just core Java. In core Java also only few concepts, mainly the OOPS concepts and the exception handling. These two are more than sufficient. Exception handling also is not must and should, but you should know the OOPS concepts like encapsulation, data abstraction, inheritance, almost. So I will be covering this. I will be covering some 2 to 3 Java programs. Then I will move to actual MapReduce practicals. Okay. So this is about development. And again, there is a huge gap when you do. Suppose take a requirement, take small use case. Take Airtel and Vodafone, two guys. So Airtel got some 10 GB of data today, some new data, and Vodafone also got some 10 GB of new data today. So they got a requirement. First you got some new data, right, 10 GB, okay. Can you give me analysis like, okay, who are using 3G services more in between so and so timings, like 7 to 11, 5 to 11 p.m. or something, 2G services, something between 3 to 7 p.m. So phone services or SMS services, different services. Again, they will categorize these requirements at some level. Okay, so they come with some requirement. So these two guys have 10 GB of data. So here among these two guys, who could develop the analysis, who could do the analysis, and who could run this 10 GB of data with this analytic development and give the results first. Okay, to give the results first, he will capture the market very fast, because based on this results, right, the business team at backend, they will take decisions. They will introduce some new services, or they will introduce some new offers, and they will send to customer care, and the story will start from customer care. So like they will promote the new services or offers. Okay, so they could capture the market very fast. Who could do this analysis very fast. Okay, so it's important developing these analytics using any of these ecosystems very fast. So if you do in MapReduce, okay, development of the same requirement what we discussed, let's assume if you take 1 week to development that requirement in MapReduce, because it has, you need to do the programming in any of these language. Okay, but if you do the same requirement in Pig, okay, which is taken in 7 days in MapReduce, Pig will take only 2 days, because Pig is very simple language. Okay, you don't write any complex programs there. It has some set of 20 to 25 commands. If you know that, that's it. You could do any analysis in Pig. Okay, it will take 2 days. Hive also, it will be almost similar to same time, 2 days. If you go to something Impala, right, still it will be less. It will be like 1 day or 1.5 day. Okay, the development, still it is more easier. And again, while processing the 10 GB data, what Airtel or Vodafone holds. Okay, when you process the 10 GB data using MapReduce, that means after developing the application in MapReduce, you are running the data with the developed application. Let's assume if it takes some 3 hours of the time to process this 10 GB of the data in MapReduce, if you do the same functionality and the Pig, and if you run the Pig functionality what you developed on the same 10 GB data, it will take something like 2 hours 20 minutes, 2 hours 15 minutes, because Pig is very efficient compared to MapReduce. Okay, and there is story beyond that. We'll come to that point. Okay, and Hive still better. It will take still it will reduce the time. Like from tomorrow, it will go for even 2 hours. Okay, not 2 hours 15 minutes. But if you go for some powerful systems like Storm or Impala or something Nahout, okay, these things, right, they will run very fast. Okay, Impala and Storm or Scala something, right, they will run like in 40 minutes, 30 minutes. Okay, there will be huge time gap if you go to this powerful advanced ecosystems. Okay, so there is again performance wise there is a gap between these ecosystems. So And again, there is a purpose with each ecosystems we are going to see in the course. Okay, so it's very important development wise. Okay, so this is main advantages of the big data. Okay, so let's go to presentation. So we'll discuss more in presentation. Then if you have any doubts, we can discuss. So this is about myself. So what is big data? Okay, so if you see the data available in 2009, the world is 8 lakh petabytes. But by 2020, they are estimating like the data will be in 35 zettabytes, which is 35 billion terabytes. Okay, the data growth size is very fast day to day in the world. Okay, so this is the statistics given by International Data Center. Okay, and the data whatever we are generating, it's mostly unstructured. As we discussed, it's mostly more than 80% is unstructured, and they cannot simply thrash it or dump it, the unstructured data. They should able to process it and analyze it. Okay, we should help them to take some business decision and improve their business revenues, improve the increasing the customer count, and giving the competition for the customers. So for that, they should able to do this analysis as fast as they can. Okay, they should able to analyze the data, whatever the data existing, if it is structured or unstructured. They should able to analyze it very fast. Okay, to analyzing the data, to do this data analytics, first of all we need to understand the data, and we need proper storage infrastructure. Like we need proper cluster setup to store the data, and we need good processing framework to process the data, that means to develop the applications. Okay, and we need good network environment, and of course these are all expensive with the existing tools or existing environments, like warehouse systems are traditional systems. Okay, which are little expensive, and they are slow and delayed because they do follow sequential processing, which are time taking, and they are more expensive, and they face hardware failures more regularly. Okay, so the alternative is a big data. So this is how the clusters looks like in Hadoop. Okay, they will maintain this. Each one is a node here. Okay, this is a rack. Okay, and each one is a node. Okay, so the biggest cluster, Hadoop cluster, currently has by Yahoo. Yahoo is running on 42,000 node cluster, completely on top of Hadoop. Even not only Yahoo, Facebook, LinkedIn, many banking applications like Bank of America, Ericsson, many are running on Hadoop only. I mean, most of their applications. So these are the few sources who are generating data in high volumes. The New York Stock Exchange generates about 1 TB of the data per day, the trading data. Okay, and Facebook is approximately holding 10 billion photos, taking up to 1 petabyte of storage. Amount of the data generated by machines, this is important. We know if you go to internet, we have some millions of websites are available. Millions of websites are available. Okay, and every website, okay, generates weblog. Each website will generate one weblog, and they will generate weblog every day. Okay, so if you see, there are millions of sites, millions of weblog, and daily logs. Okay, so again, this weblog size, there will be huge size. Okay, there will be in gigabytes. Okay, so to process this weblog site, we need, this is one source again. Amount of the data generating by machines will be even greater than generated by people. Machine logs, sensor data, GPS, retail transactions, and YouTube per minute 72 hours of video is being uploaded. Okay, so if you take an example like eBay or some e-commerce site. Okay, something I logged into eBay site. Okay, eBay site. Something I searched for some product like iPhone 5s something. Okay, so when I do search for iPhone 5s, okay, so if you see in the next some 10 seconds, 20 seconds, you will get a beautiful bar at bottom in eBay site saying that, boss, we have this many iPhone 5s are available from different vendors with different offers. So that means the time when you started searching, the time when you started showing you recommended products for related to iPhone, the 20 seconds is run this analysis at backend based on what you are searching. So it will take the word what you are searching for the product what you are looking for. It will at backend in Hadoop system it runs this analysis and it will recommend you for your search context. This is the recommended products for you, with recommended offers and recommended some from vendors, from different vendors. Okay, so if you could get that in the same site eBay, right, then you don't go for other site. If you could get whatever the product, I mean with the best offer you got it in eBay itself, you won't go for other site. That means it's very important to recommend the customer based on his interest and based on his sentiments. Okay, these are many things like it's something like an e-commerce. But if you go to any other domains like banking, not banking, like something banking also, like stock predictics, stock, how will it be the stock? If I go for any stock, how will it be the predictics? Like how will be the stock price is going to up in the next coming week, or will it be going down? Okay, it's analysis it will do based on the historical data and based on the business, the stock decisions, the decisions taken on the stock recently. It does this analysis and it will give you predictics. Okay, not only that, even company sales, okay, company sales based on the historical sales data, you do analysis and it will tell you this is where you have. I heard like something in US recently they introduced one capsule, miracle small capsule, okay, in healthcare domain, and this capsule, right, the patients can take the capsule and this capsule will contain a small chip. Okay, patients will take capsule and this capsule will contain small electronic chip, and this chip what it will do is daily it will send data to the server. It will send data like what you are eating, what you are drinking, how is your health condition. Day to day it will send you the reports, the data, the status to the some centralized server. Okay, so the customers, right, the patients every month they will get a detailed report from the respective insurance organization. But your diet plan is this, you are eating this in the last 1 month. Okay, you are drinking this, you are taking this kind of food last 1 month, the percentage of junk food, percentage of good food. Okay, so how your heart condition is, everything based on this, and also they will recommend like in future you should follow this diet plan, okay, to avoid any unnecessarily diseases or something. Okay, so this is something like analysis, okay, like real-time analysis. So again, if you go for analytics, we have many use cases like this. Okay, predictive analytics and something again, batch analytics. Okay, something like forecasting the next year sales, predicting the site visitors, given past historical and seasonal trends. Okay, something if you keeps on visiting for same product for 2 to 3 times, so that's it, like Google Ads, right? They do recommend the same product. If you go to any site, you will get the same thing. Okay, something again predicting about the like cyclones or tsunamis. Okay, anything like that. Performing clickstream analysis of company website. This is something what I said on eBay. Okay, based on such context or clicks. Okay, like tweets. Okay, so there are many kind of analytics use cases. We are going to discuss. We are going to do a few use cases in our examples. And the data is divided into unstructured and structured. We have many ecosystems that process this unstructured and some ecosystems to process this structured data. And job market, obviously. Okay, so it is with current technologies. For one job, 187 guys are waiting in the queue with traditional software, traditional frameworks. Okay, but it's in opposite way for Hadoop, because Hadoop started recently in 2011. Okay, so there is a huge gap of professionals in the IT market. So people, companies are looking for professionals. Since they are not finding the required people, what they are doing is they are providing internal corporate training and they are recruiting into their projects. Okay, there is a huge market for the Hadoop. Okay, Hadoop and data. Mainly there is a I mean by 2000 it's a I mean it's been given in few articles in this year, like 2015 and 2016. There will be, I mean, huge requirement for data analysts and data scientists. Okay, there will be huge demand for these two guys in the coming years. Okay, so there will be huge requirements in, that means expecting 3 lakh jobs in big data by 2015. And the US has a good market. Out of complete 100% of big data market, US is capturing 65% of the big data market. It's really hot there now, the technology. Okay, and following by India, following by European countries and UK. And even the compensation is good. In US they are paying something between $150 to $230 per hour if you are very proficient in big data. That means if you are strong in at least 2 to 3 ecosystems. Even myself recruited from our consultancy, 3 guys in US paying $180 per hour. Okay, so India also they are giving good compensation between something like if you have some 4 to 7 years of experience, they could give something 15 to plus something around 15 to 17 lakhs based on your proficiency again. So big data is not a software or framework, it's a methodology, guys. Okay, we are going to discuss in detail about big data in the coming classes. It's a methodology. Okay, it's a methodology that could process high volumes of the data. Okay, high volumes of the data like terabytes or petabytes of the data on distributed systems which runs on commodity hardware and should be able to process your data within tolerable elapsed time. Okay, so this big data actually works on a principle called 3 V's. Okay, 3 V's. This is 1 V is volume. It can handle terabytes to zettabytes of the data, and velocity something. It can handle the batch processing, batch analytics, streaming data. That means the real-time analytics. And variety is something. It can handle structured, semi-structured, and unstructured data. These are the few differences with the traditional systems and big data. We'll discuss them in the classes. So these are the few sources for big data applications like web applications, e-commerce, shopping, banking, retail, and many machines. Okay, so as I said, we have both structured and unstructured. So this is like out of the complete data, it's only 20% is structured data and remaining 80% is unstructured data. This unstructured data is going to play key role to taking business decisions and to invent the new principles and standards or new or like something like to improve their business. Okay. So we have many categories of analytics: image analytics, biometric analytics. We are going to do one use case on this biometrics. Okay, what kind of biometrics, like something like this fingerprint scanning, matching. Okay, how do we do it using big data? And text analytics, like something Facebook recommendations. We know, right, in Facebook and LinkedIn, if there is any mutual friends, it will recommend you automatically to add them. Okay, so we are going to discuss this algorithm. We are going to do practicals also, both the Facebook algorithm and LinkedIn algorithm, the recommendation algorithm. So again, in coming to market, we have many number of Hadoops available. Okay, so actually the history started like this. Okay, let me start. In 2002, okay, a person called Doug Cotting, he started a project called Nutch. Okay, Nutch for distributed data processing. Okay, for to process, he is trying to develop a framework as a Nutch project to do distributed data processing. Okay, to process the data on clusters. So when this guy is doing this, okay, in 2004, Google released 2 papers called Google File System and MapReduce. Okay, Google MapReduce. Okay, this Google file system is for distributed file system, and Google MapReduce is it's a framework for distributed data processing. So once this papers is released, this person Doug Cotting, he got inspired from these two papers and implemented the same concepts in the Nudge project. Okay, and he called them as these two concepts as here distributed file system and MapReduce. Okay, so later the person Doug Cotting, he became the employee of Yahoo. Yahoo recruited him, and once after Yahoo recruited him, Yahoo renamed this project Nudge as Hadoop. It is in 2006, I guess. Okay, in 2006 they renamed the project as Hadoop, and they renamed these two things as HDFS, Hadoop Distributed File System, and MapReduce. Okay, so this was done around 2007. Okay. So actually the first version of Hadoop is released in 2008. Okay. So at that time, if you want to do analysis, data analysis in Hadoop, you should at the time you should be able to do only in MapReduce. At that time we don't have these ecosystems what we discussed here, right? You should be able to do in only MapReduce. But as we discussed, MapReduce you should know this programming language, and doing this programming language again they involves with a lot of complexity, doing Java programming or C++ programming. Okay, and they will take more time to implementation, which is not expecting, because the analysis needs to be done very fast, the development should be done very fast. Okay, so at the time is the reason from 2008 to 2011, right, the Hadoop was not into limelight. That means it was not many people don't know there is something called Hadoop. Many companies also didn't start using Hadoop because it has tight integration with MapReduce. Okay, so at that time Facebook is also using Hadoop. That means they used to do MapReduce programming initially, but later since they saw the complexity and the pain of doing MapReduce programming, they started one project called Hive, internal project. Okay, Facebook. What they did is they created wrapper on top of MapReduce. They created abstraction wrapper on top of a new framework called Hive on top of MapReduce. They made simple. They made the development very simple. Okay, so Hive is something like SQL. If you don't know SQL, how to write SQL queries, you can straight away start working on Hive, because Hive follows same query syntaxing and query keywords when you write the queries. Okay, they created wrapper on top of this. So whatever you do in Hive, they will convert. Hive will take it to convert it the queries into MapReduce programs. Okay. So once this Hive once Hive is released right into market, it's become very popular. So along with the Hive, at the same time, the Pig has been released by Yahoo. Pig is also again one more wrapper on top of MapReduce. So these two guys made the development very easy and they become very popular. Okay, so is the reason from then the companies have started using, from 2011 started using the Hadoop. Okay, so while these guys are going, the many ecosystems slowly started evolving later, like HBase, all these things, Cassandra, MongoDB, Mahout, and everything, Impala, everything is in. Okay, Impala is still in release phase. It's not yet completely developed. It's still in beta phase. Okay, all these things came and made the Hadoop data analysis very easier in Hadoop. Okay, so when these guys are doing this, the industry big guys like IBM, Oracle, Microsoft, many big guys, what they did is they developed their own Hadoop. What they did is they developed their own Hadoop. Nothing. What they did is they took this base Hadoop. Okay, so after Yahoo releasing, right, then it's been taken by Apache. Apache is taking care of releasing and maintaining the Hadoop. So IBM and all these guys, what they did is they customized this Hadoop. They used to take this Apache Hadoop. Okay, and they developed something called Big Insights, IBM Big Insights. That means they provided some beautiful GUIs for development and they customized it, and they are selling this IBM Big Insights for license. It is a licensed version. If somebody wants to use IBM Big Insight, they have to purchase it. Similarly, Oracle also, Oracle Big Table is also purchased a licensed version. Even Microsoft is doing now. It's also licensed version. There are many licensed versions. But the base Apache Hadoop is still open source. And there are few more companies founded, like Cloudera. It was founded in 2009. Okay, so Cloudera, what this guy is, they are very smart. They recruited the dog cutting. So this guy becomes the employee. So Cloudera also customized this Apache Hadoop. They are releasing as Cloudera distribution of Hadoop, CDH. Okay. They are also providing a free of cost, but they will charge for the support. That means if you have any API level issues, if you want to fix it, okay, they will fix it, but they will charge for that, so that you don't need to worry about the API level issues. You can concentrate on your business development. Okay. So along with Cloudera, again, two more companies like Hortonworks, Greenplum has been found. These guys are also releasing their own Hadoop, but these guys are also open source only. But there is something called enterprise version in Hortonworks, that is a licensed version. Okay. So these guys also provide support like Cloudera. Okay. So that is how the many Hadoops came into market. Hortonworks, Cloudera, Mapper, IBM, Vetica, Greenplum, Neteja, Astrodata. Okay. But these are all licensed versions. Even this is licensed, this is licensed. These two are open source. Okay. So for all these guys, the base is Apache Hadoop. So in our course, we are going to cover Apache Hadoop. We are going to do installations of Apache Hadoop, both single node, multi-node, and we are going to cover then Cloudera Hadoop. Okay. Installation of single node and multi-node. And then we are going to cover how to do installations of Hortonworks and single node, not on multi-node. Okay, Hortonworks and single node. Okay. So Apache Hadoop is a software framework that supports. So Hadoop is actually, it's a framework. Okay. It's the same framework that supports data-intensive distributed applications at free of cost. It enables applications to work on the clusters with thousands of nodes and handles petabytes of the data. Actually, Hadoop concepts was inspired from Google MapReduce and Google File System, and Google again took this MapReduce algorithm by inspiring from Indian algorithm only called Mumbai Dabbawala. Mumbai Dabbawala, there is it's a Six Sigma certified business model. Okay, they inspired from this business model and they made it as an algorithm and they implemented in MapReduce. Okay. So this Mumbai Dabbawala is right, is Sigma certified. They are 99.99% accurate. They do deliver lunch boxes daily to the offices from the homes, okay, daily afternoons. So out of some 6 lakh transactions, they made only one mistake in delivering 6 lakh lunch boxes. Okay. So remaining 5 lakh 99, and they will deliver within time. They won't make even 1 second late. Okay. So that is the efficiency of them. Okay. So this is history of Hadoop as I discussed. It's a nudge initially, then Google released the papers. He added into nudge. Then Yahoo recruited this guy. He renamed it to Hadoop. So at the time, Facebook launched Hive. So similarly, at the time only Yahoo launched Pig. Then Cloudera is founded. He became the employee of Cloudera. Okay. So the story is continuing like this. So there are many users for Hadoop. Okay. Yahoo, Facebook, mostly social networking sites, even this e-commerce sites. Most of the sites are running on Hadoop systems. This is the Yahoo cluster with 42,000 node. Okay. And there are many use cases where Hadoop suits well for development to do analysis, like financial domain, net domain, internet, retail domain, healthcare domain, telecom domain. Okay, you have many domains. We are going to discuss these domains in detail. Okay, in the course. So Hadoop comes based with mainly with HDFS and MapReduce, the Hadoop framework. But these are all ecosystems evolved. So we are going to cover Avro, Cassandra. Chukwa we are not going to cover. Chukwa is between clusters. Say assume I have one cluster in Hyderabad, one cluster in New York, one cluster in Sydney. Hadoop cluster. If I want to coordinate these 3 clusters, there is a separate utility called Chukwa. It is for completely administrators. Okay, we are not going to cover that, but HOS we are going to cover in detail with examples and POC also, proof of concept. And we are going to cover Hive, we are going to cover Mahout, we are going to cover Pig, we are going to cover Zookeeper, we are going to cover Scoop, Fuji, Flume, Mahout, R Hadoop. Okay, R Hadoop, a Hive, Pig. Okay, of course the base HDFS and MapReduce. So leave about HDFS architecture now. It is a huge topic. We can start now. So this is about market. US is a big market, following by India, then UK and Europe. Okay. So skip this Facebook. They are using completely Hadoop. So this is about course curriculum, guys. We are going to start with what is a cluster, what is a Hadoop cluster. Okay, how Hadoop cluster, what is the typical workflow. That means when you develop a data analytic application, okay, data analytic application, so where to start, where to end. The typical workflow, we are going to discuss each step in detail. What actually will you do when you write data into Hadoop, when you read data into Hadoop, how to do MapReduce programming, how this MapReduce runs. It's very important to learn the MapReduce architecture. You should know the concepts and how it's running very well. Okay. So it's very important, don't miss that beginning. 10 classes. Okay, 10 classes is the core. We are going to explain the completely MapReduce concepts, how it runs. Okay. Then MapReduce, these are all internals. We are going to see some complex algorithms in MapReduce and simple algorithms also. And how to do unit testing in MapReduce. These are all complete internals of MapReduce. There are some MapReduce advanced features. How to do optimization in MapReduce. How to improve the performance of MapReduce programs. Then we are going to see peak, installation, configurations, architecture, complex operations, UREFs, macros, okay, piggy bank, then Hive, then NoSQL database like HBase. We start with HBase, and we're going to cover Mahout, how to do data mining in Mahout, then R Hadoop, okay. Then we are also going to cover Scoop, Fuji, Impala, Flume, Avro, MR Unit, Zookeeper, Amazon Web Services, Amazon Cloud. Then we are going to see the latest architecture of Hadoop app. Then, then admin concepts. Admins like installations on single node and cluster, configurations. We are going to do Apache installations and Cloudera installations on single node and multi node. Along with that, we are going to cover what admin tasks will be, how to do benchmark of a new Hadoop cluster, what the monitor task admin do, how he does this monitors, what are the tools available, monitor tools available in Hadoop, and what is the routine admin task daily he will do on Hadoop cluster. Something daily he has to do run some commands. It's a daily daily tasks that he needs to run on Hadoop cluster. Okay, and how to handle failover scenarios in Hadoop. Okay, and how to adding new nodes and removing the existing nodes from the Hadoop cluster, commissioning and decommissioning nodes. So this is about course curriculum. Of course, how much I said, it also depends upon your efforts. Okay, so during the course days, the training period, you should read at least 2 to 3 hours daily. I will be sharing you the company material, the soft material. Okay, and virtual machines also, I will be sharing you after installations. So of course your laptop is needed for installations, and the cluster mode I will show you. We will be doing the cluster mode also, and I have one cluster. I will be providing you the cluster credentials. You can access it from here, but don't corrupt it. Okay, because if something goes wrong, right, it will take again time to fix that in the cluster. Okay, and of course along with this we'll be sharing you the complete materials. I have the analytical material is there. of all the things: books, presentations, installation manuals, certification dumps, labs, POCs, projects. Okay, so everything we have. Material wise, there is no need to worry. Okay, labs. Okay, resumes, some sample resumes, and also we'll be sharing you the softwares required for installations, and all the sessions what we are going to for online sessions, they will be recorded and will be shared with you. Okay, so this is about my from my side, guys. So if you have any queries, we can talk now. Swati, can you could you unmute the guys? Hello. Hello, Swati. Swati. Hello. Naveen. Naveen, could you talk with Swati and ask her to unmute this? Unmute the students' phones. So if they have any questions, they can discuss here. I think maybe after what? Okay, guys, maybe you can put here. I mostly need to know the kind of projects you will provide. Okay, good. So here the kind of projects is I am going to. Okay, great. Thank you. So the project I am going to cover my real-time project, two projects. One is the real-time analytics and Amazon what I did, right? That one I am going to share you. It's for CRM application, it's for call center. Okay. And one more project, it's a Dell project, real-time project. How the Dell they are doing their server management using Hadoop cluster, and how they are something like we know, right? The servers will fail frequently. So they did some analysis like why the servers are the reasons beyond why the servers are failing frequently. This analysis also, that project also I'm going to discuss here in the course. And along with that, I'm going to see this friends recommendation algorithm, the project, how it been implemented, and along with that, we'll be seeing that image, finding the duplicate images. I mean, if you go to, suppose if you go to Facebook, right, if you keep cursor on any photo, right, it will show you the name. So the image detecting, okay, that algorithm also we are going to cover. And along with that, I mean, there are some more use cases we are going to do with exam, I mean, programmatically. Okay, guys, let me know if you have any more queries, please. So the course will take 70 hours completely, 65 to 70 hours, including installation. Okay. So next is, I mean, the number of days I cannot say because on daily it will take 1.5 hours. So if it is holiday, right, I will take some 2 hours also, 2 to 2.5 hours. And again, something I heard like you guys will be free till Jan 6. So till Jan 6, I'll be taking more classes. After Jan 6, I will take on weekends as per your convenient. I can take on weekdays and weekends also, but as per your convenient, I can take it. If it is only weekend after Jan 6, I will be taking on weekends some 3 hours class. Saturday 3 hours, Sunday 3 hours.
Nice.
And just yeah, I already shared. I divided it based on each topic wise. Okay, yeah, topic wise I divided the how much time it will take and shared with Swati. Maybe Swati will share you. Naveen, please share with them only. And also, yeah. And also Java refreshment classes. Once after completing the MapReduce concepts and their installations, before going to MapReduce practicals, at that time I will give you Java classes. I will be taking 2 classes, then we go for MapReduce programming. Any more questions, guys?
Right. This is Pawan here. Just a question regarding the MapReduce and the other tools that we were talking, like Hive and Pig. What I get to know is, given an option, it is always better to use Hive, or is it still necessary to know the concepts of MapReduce?
Pawan, yeah, good question. See, whatever ecosystem you use, the ecosystems I mentioned, Pig, Hive, HBase, or everything, it's always good to learn MapReduce concepts and then learn ecosystems. Even you don't work on MapReduce programming here, but unless you don't know how MapReduce runs, okay? So it's important to know how MapReduce works, not important how to do programming in MapReduce here. Because unless if you don't know how MapReduce runs, the architecture, how it is designed, even if you know Pig, Hive or HBase, you could do the programming, but you cannot improve the performance, you cannot optimize your program unless you don't know how it is running at underlying, at bottom level. Okay. It's very important to know the MapReduce concepts, then only learning the ecosystem.
Okay, yeah, thank you.
Thanks, Paul. Okay then, somebody has any questions? If you don't have, right, you could contact the Swati. So once everything is fixed, right, we'll fix some one date and we'll start the course. Okay. Naveen? Naveen?
Yeah,
Yeah.
yeah, I can.
Yeah, so please coordinate with the Monday.
Okay, fine.
Okay, please coordinate and let me know, okay, so that we can start one. Thanks, guys. Thanks for your time. Okay, good night. Take care. Bye.
Yeah, thank you.
Hello. Hi, Pawan.
Yeah, hello Swati, yeah, tell me.
Yeah, I will send you the course content divided with the number of hours.
Yeah, fine, I'll send it across accordingly.